Hello everyone. Today I'd like to present to you the drilling process for this tall cabinet unit, as we have here in our project. A side-by-side refrigerator and above it 2 overhead cabinets. Space tower with boxes and an extension. We will start by drilling the overhead compartments. We have a front to the left, a front to the right. Today we will drill the column structure. But generally, it is a machine in my company that takes us through the entire process of drilling all the holes necessary for furniture production. When we start operations, we will first perform horizontal drilling. Remember to, when lifting the gauge frame, remember to retract, to move the bumpers to a safe position, that is, to the rollers. This is approximately 50 centimeters, so that the bumper does not enter into a collision course, whether with the side guide or with the height adjustment of the pressing beam. We just need to move away. We need to determine the exact spacing for where we'll be drilling. The top and bottom panels have a depth of 656 millimeters. And the side panels are routed for the backings of the hanging cabinets, which are 676. The spacing we'll be drilling, I believe the correct measurement should be 576, which is 18 multiplied by 32, if I remember correctly. That gives us a final result of 80. Let's divide it by 2. We have 40 millimeters from the edge for the support, and the same for the confirmat screw. To achieve a 40 millimeter dimension parallel to the head, we'll use a 10 millimeter spacer. Because on the first drill bit we have 18 plus 32, on the second, 50. The spacing is 576, as I mentioned earlier. 18 multiplied by 32 gives us an even spacing, which means we'll have drills of the same color rotating in the same direction. So, now, we're going to set the drilling depth for the confirmat fastener. We'll be drilling with a 4.8 millimeter drill bit, and here we will set the depth to 40 millimeters, so that with a small margin we can properly drill into the top panel's depth. I don't know about you, but I allow the tops and bottoms to extend past the sides by a full millimeter. When working with 1 millimeter PVC edging, I therefore placed a 10 millimeter spacer beneath the tops and bottoms, and for the side panels, I will reduce that to 9 millimeters. Let's start a stopwatch and see the actual time it takes us to complete these drillings. The stopwatch has just started, and we are now commencing our drilling operation. All right. Okay, we've completed all the horizontal drilling in the 4 wreaths. I'll set them aside on the easel as we won't be drilling anything more in these wreaths. Now we're moving on to drilling the sides, so we are lowering the gauge frame to its vertical position. First, we will perform the through-hole drillings for the confirmat, but in the meantime, we can also set up the bumpers for the supports. There should be 1 shelf in this overhead cabinet. The height of the overhead cabinet is 550, so the opening we get is 260 away 6 millimeters. Since we are drilling quite deep structure, we will have to re-equip later with drills. From one side to the other, but conformationally. And we still need to change the distance. Since we are releasing the wreath at the side by 1 millimeter, I will reduce the distance from 10 to 9 millimeters. And then we will perform through drilling. And now the right-hand sections. All right, we did it. All the through holes have been drilled, so now we'll be drilling the shelf supports. So what exactly do we need to do next? We're going to remove the central drill bit because there will be 2 supports on each axis. We have to change depth of drilling. First, we're going to mirror the left-hand sides. Now we'll be drilling from the right-hand fence, so the drill bit needs to be repositioned. And the distance too. Okay, we have more drilling to do. A straight guide on one left side and one right side. So at this point, we are arming ourselves at a spacing of 32 millimeters. The first hole for my guide is at 21 millimeters from the edge. We need to make one left side. And the other cabinet on the right side. Let's set the distance of the guide on 80. It might as well have been 100. It depends on what you prefer or what the situation requires. Construction. We insert a spacer 29. If we were to have more drilling, we would also fix a spacer on the other side. But because we have a very deep, quite deep construction, it would be too tight between the templates. So we have to do it first on one side, then on the other. We have a drilled hole in the material. We need to change our drilling equipment because the drills are clashing with the structure. It's due to the deep foundations. With standard cabinets up to 60 centimeters in depth, we wouldn't need to perform these additional steps. We would do it even more simply. Okay, all set. We've got the pre-drilled conformat screws, the shelf supports, and the runners. So, essentially, everything that allows us to assemble this piece of furniture. I also wanted to show you the drilling process for the deep cabinet of the Space Tower, specifically on the Marivaux box. The setup is unusual in terms of depth. It's almost 700, so on the machine, we operate with virtually no clearance without disassembling the side guides. We'll drill it. The placement of the guide rails, conformat fastening screws, and the drilling templates for the hinges. For 155-degree zero protrusion hinges. As always, we start drilling with horizontal holes. meaning we lift the jig frame all the way up. Just one final look over. Are the bumpers fully retracted? Are we in a safe position to prevent the machine from moving into collision? We're lifting the gauge frame up, and we need to establish the spacing. The spacing of the conformats where we will drill this installation. The depth of the cornice is 576. It's quite a large drill, a few 10 centimeters. So, generally speaking, we have guides here, which means this entire structure didn't need to be any deeper. 5, 7, 6, that's the depth of our top panel. 5, 7, 6, I think we'll drill it at a 480 millimeter spacing. An odd spacing. Okay, we'll put in the third drill bit. We will set the drilling depth to 40 millimeters. So we will leave 8 millimeters as a margin. We reset, begin. Okay, this post only has 2 sections. We won't be making any further drillings into these, so I'll go ahead and place them onto the sawhorse, and then we'll get ready to drill into the sides. For that, we'll need a trestle. We're now moving on to drilling the sides. We've lowered the frame for vertical drilling. I'm setting it to 9. We are breaking the stereotype that a multi-spindle drilling machine is exclusively used for small minor components, such as drawers and hanging wall cabinets. On MS-704. No problem, we can... Also such a deep structure as this, approximately 70. Drill centimeters. To be honest, there's quite a bit more enjoyment involved here than if we were just drilling into those typical standard core samples at depths like 510 or even 560. But we will calmly perform all the operations necessary to assemble this piece of furniture. We will mark where we have the bottom so we don't make a mistake when marking the guides. Marivaux Box Guide is in a layout of 224. The first hole we're interested in is 37, so the second one we drill is 50. We assume a distance of 13. Set the value to 224. I calculated the guide positions earlier. We will have to make the very last hole from the top. All right then, for the drilling operation on the patient's left side, the entire team is now fully prepared. We still need to adjust the depth of the holes we're making, because the drilling won't be going all the way through. And then we'll mark the guide rails. We will cover the distance. We must carry out one drilling from the very top. Our left side is now ready. We are completely ready. Okay. So we have marked the guides of the entire space tower. Now we just need to drill. Guides under the hinge mounts. The front opens to the right side, so I had previously set the positions of the guides. Aki. We have full flexibility in planning the guides and their specific positions because we are working on an axis that is perpendicular to the spindle head, which is completely independent of the 32mm system, so all the spaces that I have carefully calculated. They're not really dependent on anything. The post's height is also quite unusual, 1,460. Let's take the distance. And the final guide we will need to drill from above. This is the finish. There were a few operations, shifting drills left and right, and so on. But generally, we have the full set and can assemble the furniture. So if you'd like to process components for custom cabinetry this way, this machine was specially designed for producing non-standard furniture, so that you can make a post like this in about 14 minutes.